Okay, so we're being asked here to identify the outliers of this entire data set. And what I haven't taught you guys yet is how to find outliers as well as how to identify interquartile ranges and z-scores, which we'll get into later. But to identify the outliers, you first need the interquartile ranges. You need quartile 1 and quartile 2. I mean 3. What this basically means, um, well, actually, it's probably better if I just demonstrate it to you. So if you remember what medians are in AP Stats, like the middle of the data, um, we can just get that by like counting down and up. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. Hold on, did I count this right? 4, 4. Okay, wait. 6, 3, and 6, 3. And you end up with 9.6 as your median. So you can write right over here that your median is 9.6, right? That's the middle of all your data. And so to find the interquartile range afterwards, it's basically the middle of the data in this section below the median and the median of this data that's above the median. So for our first quartile, for quartile 1, what we can see from 9.6 to 20, we can say 1, 2, 3, 1, 2, 3, 4, 4, and quartile, our first quartile will be 5.4. Then you have quartile 3, which follows the same concept. 1, 2, 3, 4. 1, 2, 3. Oh no, my pen died. I'll do this with my finger. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And that will give you 12.7 if I read that correctly. Yeah, that would give you 12.7. Okay, so that's what and interquartile range. I was just gonna say I didn't even define that yet. Okay, so basically what interquartile range is asking you to do. So you know how when we were calculating the range, we would just subtract the minimum from the maximum value in distributions, right? Well, here we're gonna have to be subtracting the first quartile median from the third quartile median. So to find the interquartile range of this data set, you're gonna have to do 12.7 minus 5.4. If you want, you can put this into your calculator. You don't have to if you can solve it in your head. But this would give you 7.3. And actually, we can write that to the side. IQR 7.3. All right. At this point, to solve for the outliers, you don't need the median anymore. So I'm going to erase the median for now. Bring this all up over here. Okay, now to find the outliers, there's two different ways. You have to solve for the low outliers and also solve for the high outliers. So for the low outliers, we're gonna say LO. Well, actually, we'll symbolize it as LO as a variable. You're gonna have to do not equal. Low outliers are gonna be less And the first quartile median minus 1.5 times IQR. That's a terrible looking Q. Let's died again. And for your high outliers are going to be greater than the third quartile median plus 1.5 times the IQR. And we can actually plug this into our calculator. So for our high outlier, you would have to plug in 12.7 plus 1.5 times the IQR, which is 7.3. And when you do that, you would end up with 23.65 for your high outliers. And for your low outliers, you would want to do 5.4 minus 1.5 times 7.3, and that would give you negative 5.55. Okay, so what does this mean conceptually? Well, this means that there are low outliers in this distribution if they are less than negative 5.55. And in this distribution, there are no numbers that are less than that. There aren't even any numbers that are negative. So we can cross that out. We know there's no low outliers in this distribution. Whereas when it comes to the high outliers, any data point that's bigger than 23.65 is an outlier. And so you would end up with these two numbers, 31 and 33, because they're both bigger than 23.65. So your high outliers would be 31 and 33. And that is how you end up with your outliers. Okay. Now let's talk about z-score. And hopefully my pen will comply with me for once. Okay, so first things first, we need to know the formula for z-scores. So for z-score, the formula is going to be any value point minus the mean divided by the standard deviation. I'm not sure if I went over this in the last video, but this is the formula for z-score, okay? I'm going to put it up here just for future reference. Oh, let me move that up a little bit. Yeah. Oh well. Okay. All right. So when it comes to z-scores, when you're starting off with z-scores, actually, you usually do this with normal distributions, aka with distributions that look like this, like a bell curve. In these distributions, as we went over in the last video, the median and mean are both going to be at this data point. And so we can already see that the mean and median is going to be equal. It's going to be straight in the middle. So let's actually make an example of this. So let's say we have 155 as our mean, and our standard deviation is 3. Now what that means is that, oh, and perhaps it's better if I go over the empirical rule here. So the empirical rule basically summarizes like the percentiles of each individual based on where they end up in this distribution. So let's say you end up in any of these in these two spots. This is 34, 34. So this altogether makes up 68% of the entire sample. Whereas these two, um, are about 13.5 here, 13.5 here. So from here to here, it's about 95%. So 95% of all individuals will be in this group right here, from here to here. And then from here to here, it would be, I think it's about 99.5%. And then the vast minority of people are either at very low or very high. Okay, so moving back to our example. So we have 155 as our mean, so we can actually write that over here. Now, let's say we want to find the z-score at, say, I don't know, 140. So what you're going to have to do, plug in x, which is 140, minus it by 155, which is your mean. Divide all that by 3. So 140 minus 155 is negative 15. Actually, let's not do 140. Let's do 149. 149 minus 149 minus 155. And you end up with a z-score of 2. Okay, now basically what you have to do here, you probably won't know this by memory, but you will be given a z-score table that basically tells you all the percentiles based on your z-score. So let me just look up the z-score table real quick. This is definitely very low. For negative 2%, your z-score would be about 0.0028. Basically, that's 2.8%. And what that means is that you're in the 2.8th percentile of that entire distribution, which is like really low. So depending on what the distribution shows or measures, that could either be really good or really bad, mostly really bad. But say we were looking for the z-score of about 160. So 5 divided by 3, you get 1.67 if we round it to the nearest tenth or hundredth. And when you look in your z-score table, so 1.6, 1, 2, 3, 4, 5, 6, 7. Okay, so your z-score will be not 0.95. It's really annoying to look at it, by the way. 1, 2, 3, 4, 5, 6, 7. Okay. You had 95.25% as your average. That basically means in that distribution, if you have 160 in this entire distribution, you are in the 95.25th percentile, which basically means there's only a vast minority of people who are only ahead of you in this distribution. So again, depending on what the distribution measures, that could either be really good or really bad. You never know. But that's basically how z-scores work. Now, let's say someone is in the 91.92 percentile. That's their percentile. And the mean in this distribution is, say, 60. And the standard deviation is about 5. Now, you need to find the value they got to be placed in this percentile. Whoops, that's not what I wanted. Okay, let me use my pen now. Should have given enough time to rest. Alright, so first what you're going to want to do is you're going to want to look back at your z-score table, see which value corresponds to 0.9192, and that will be a z-score of 1.4, because a z-score of 1.4 gets us 0.9192, which is the percentile we were measuring before. So now you have this formula, the z-score formula. Ah, oh, died again. Oh man, my pen is very hesitant. And you're going to end up with this formula, but you're solving for this variable, the x, the value that you ended up with to get that z-score. So what you're going to have to do is do a little bit of rearranging. This is where the physics comes into play. And now you can solve for x using this rearranged formula. So you can plug this in. 1.4 times 5 plus 60. And you would end up with a value of 67. Now this means that if you had like 67 in this distribution that we just solved for, you would end up in the 91st percentile or so. A little over. Technically a little over. But yeah, that's basically how z-scores work.